Good morning, everyone. Welcome back. Today we have another brand new episode of Unscripted Coding for you. For those of you new to this channel, Unscripted Coding is where I start writing code, programming, creating something right in front of your eyes. There's not a lot of foresight. There's very little planning that goes ahead of these videos. Generally, all I do is take a theme and I run with it. And in the process, you see all of the mistakes, all of the change in plans, and things that just don't work out in a very messy video in the design process. So what is our project today? Well, you see it right in front of you. I had these arrive a couple days ago, and they are Arduino Pro Micros. I opened one up so you guys can see. Let's focus this up. What are these? These are very, very, very cheap microcontrollers. Each of these you can get from AliExpress for about $3 or $4 American, and you can probably get them off Amazon for $7 or $8. So three of them, anywhere from $10 to $20, $10 to $25 to get a hold of. And what you want to do with these is you want to write some very basic logic to control actual hardware. Up until this point, we've been building apps or websites or things like that, applications. That is all housed on a computer, you have a monitor, but what if you want to do something in the physical world? What if you want buttons to click on? What if you want LEDs that blink left and right? We're actually not going to do that today. I have a very specific goal in mind, but these are perfect for that type of project where you have LEDs blinking, you have motors running, controlling very simple things. So one classic example is blinking LEDs. You attach them to the side on these pads on the left and right of the device, and you can pulse energy through the LEDs, and you can have all sorts of complicated blinking patterns. Of course, on and off, but you may have alternating lights, you may have a different timing scheme. The Arduino Pro Micro is actually fairly powerful, so they are not dead simple like Christmas lights with on and off. You can cram a lot of logic in them. So what is it we want to do? I ordered this particular one, the Pro Micro, and alternatively, if you wanted a bigger Arduino, you can get the Arduino Leonardo for the same purposes. But what I found out is special about this particular model is that it can act as a human interface device. What is that? A human interface device, HID, HID, is how humans interface with computers. Think about it for a moment. How do humans interface or interact or input things onto a computer? Generally, it's your mouse or a keyboard. There are obviously other methods, but your mouse and keyboard are the key ones. What I want to do is take this and have it do automated mouse commands. So it will pretend it is, this chip will pretend it is a regular mouse, and as far as my computer can understand, it is a mouse. But on the other side, it is doing all sorts of movements when I put it in. So the goal is to do a complex set of mouse movements and keyboard presses so that I can automate a piece of this. Now, if you're looking and paying attention to what is on your screen, you'll know that there are some other things attached to it. There are these headers that will fit right into the Arduino right here. So you can put them in this. There we go. What you would do is you would put them in, you would just solder each one of these, and you have an attachment for your hardware. I don't have a soldering iron handy, so I am really not going to do too much on the hardware side, all I want to do is be able to take this micro USB port, plug it into my computer, and do some commands. Ideally, once I am done and I have a bit more hardware to do this, I'm going to solder these on and have a button so that we aren't relying on plugging this in and out of the computer to make those commands. Instead, what we're going to do is be able to click, say, a physical button instead. Anyways, enough of me talking. Let's get into the programming. I think this should be a fairly short and simple project. Okay, so that went by far quicker than I thought it would. This just worked out of the box. There seems to be 2 included packages for keyboard and mouse. And all I did was plug in this chip to my computer here via USB Micro. Oh, and you see, once I've done that, the mouse jumped up and then press the U button. Now, you can do this however you want. I've put in, so first of all, in your setup, I've put in a 2-second delay. I think I'm just gonna bump it up to 4 seconds. Because the moment you plug that in, it's going to try and run these things. And you can see as soon as that went in, it just makes those commands. It just move the mouse, click, click, press U. And if I had 0 time and I didn't quite make these movements right, it could really screw me up. So the 4 seconds that I'm putting in here now allows me to have this editor open, and I can try and upload onto the Arduino before it tries and runs all these commands. So before, I had the press U, where it would indefinitely press on the U key and just click, 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 click. And you can imagine that if I try and upload it won't upload because of the problems involved. So right now we have a really cool demo. Okay, so first of all, we ran that delay just for safety reasons. You may want to take that out once you figured out exactly what you want it to do, but for now that's there for my own kind of safety. Then we start with these begin things. Serial begin, I think that is setting the rate at which these commands happen and the rate at which all of the hardware reacts together. So if you were sticking in a Bluetooth module or a button or something, how you transfer data matters. But this is just template code. We start with the mouse and keyboard, and then we make these commands. Very simple. We're on a Cartesian plane, and we just move down 400, down 400, right 400. So down, right, and then back up 400, and then we double click the mouse, left, and then we click the keyboard U. This has no application whatsoever, but you can imagine that if there's something you do at the startup of your computer all the time, you can have this plugged in so that you can double click your favorite app. So you may want to position it. So what I do to reset it is mouse.move 0, and let's just go something ridiculous like 9,000. That will move it all the way up to the top, and then we want to move it all the way to the left. So mouse.move 0 -9,000. that should cover most resolutions, and you would be at the top corner. And once you're here, you can kind of figure out where your applications are or whatever you want to do. So down 400, right 400, and do whatever you need in this text box and then this text box, however you want it to interact with. So that is there. Now, if you're new to Arduinos, you're probably wondering why the starting point looks like this. Well, this is your setup. So what that means is you run it right off the bat to start things off. And then you have a loop, what happens over and over and over. And that's usually how these chips work. So think about what you normally do. Again, let's go with the Christmas lights example. You set up, so you start off maybe doing some sort of check, make sure the power's right, that your inputs are okay, all of that, and maybe you have some sort of startup thing where the lights just go in one range on one at a time, just so that, just for a bit of polish or flare. And then you loop through. You do your blinking. On, off, and presumably that just happens indefinitely until you shut this off. And so in this case, we don't want it to loop, or at least I don't think I want it to loop. What I want it to do is to execute a series of commands. So setup makes sense in this test case. But if you are doing a demo, say you just want to keep your computer alive, and you just want to move your mouse left and right like this. Hope you guys can see that very easily, but I'm moving my mouse left and right to, say, keep it from going into the screensaver, or to make sure my computer doesn't think I'm idle. You'll just want it on a loop. You'll just want something like this in the loop, so your mouse is constantly moving left and right. You may want to put some delay in there so that it looks less computery, but that's your main point. But if you want to extend the project like I intend to in the future, and you want buttons on this chip, you want a physical button that you click and then it runs these commands, it is no longer in setup. What you will do is, let's pull up that sample code again. Where was it? What you want to do is pull up this this code. Okay, so what happens is you start detecting these, and then down here, all of the commands happen in this loop. And the reason for that is because what the loop is doing is it is constantly reading the serial. So it is constantly trying to detect some sort of command. I think serial makes less sense, but oh, I see. The serial is needed to move the mouse. But what you're trying to do is you're trying to read the buttons. So each of these pads, and you can't see them at all, but if you remember from a few minutes ago, each of the pads that you connect to, each of the pins, has a number. So along here I have 1, 2, 3, 4, 5, 6, 7, 8, 9, and these buttons have been assigned their pin numbers. And what you want to see is when it gets clicked. So every second, I don't know how short the time frame is, but like milliseconds, it is detecting whether that button has been clicked. And so if you click a button, you have to loop that test over and over and over. So it's a while loop. While the button is still up, then do nothing, but when you click down on it, then you run your command. So here you would have a command for up, or down, or left, or right. And that's all there is to it. When you have a button, you will inevitably move these down to your loop, and you will need an if statement above that looks like this. If digital read up button equals high, meaning it's on, then you do the keyboard write. And so let's just take this. And they have simplified this so that the up button is a number, but let's say the pin is just 1. Let me close the bracket here. And that's basically how it would look like if we need a pin if we have a button on pin 1. And of course, for ergonomic reasons or however you want, you can put them in any pin you want, and then you make these commands happen. So that's all there is to it. It was surprisingly simple and surprisingly a joy to do this. So have fun with it. I've seen a lot of people kind of just build their own personal macro commands. So if you play a lot of video games like I do, and you don't have a very nice keyboard, I know like all these new Logitech keyboards are hundreds of dollars, have extra buttons on the side that you can program for macros. You can build the same thing with a $4 chip and probably 50 cents worth of buttons if you have a local electronic shop around you. So you just screw this in. I'd probably go for a Leonardo now that I think back to it, because they already have the headers for you to plug in. You don't need to solder anything, you just need a bit of wire to plug into it. But yeah, it is a very cheap way for you to add macros. I have a friend that suggested maybe media key buttons as well. So if you want the play button or up and down volume, you can do that. But for me, what I was hoping to do was just to have some macros on the side. And with up to 16 pins, I don't think that's right. No, you probably have like 10 or so, 12 pins that you can work with, meaning you can have like 12 buttons on here that are macro programmable. So if you're a huge MMO fan or whatever, you have all of these keys and you can program it all here. So I hope you enjoyed watching that video. If you liked it, subscribe and thumbs up. If you didn't, please do leave me some constructive feedback in the comments. This is a new channel and I'd love to hear how I can improve. So thanks for watching.